Okay, example 1. The cost C in pounds and the time T in minutes of the manufacture of an electrical component are connected by the following formula, and T is bigger than 0. It says part A, using calculus, find the time for which the cost is a minimum. Calculus is a fancy word which can either mean differentiate or integrate. In this topic, we're looking at differentiation, so that means we're using differentiation here. So use differentiation to find the time for which the cost is a minimum. Now, the subject variable is the cost. The subject variable has its maximum or minimum value at the turning point. And the turning point is where the first derivative is equal to 0. Now, if the subject variable was y and the other variable here was x, then the turning point would occur when dy by dx equals 0. But instead we've got c and t. So the turning point occurs when dc by dt equals 0. So c will have its maximum or minimum value when dc by dt equals 0. Okay? We're then going to solve that equation to get the value of t, to get the time at which c is a maximum or a minimum. But then we've got to then prove whether c is a maximum or minimum. We then will have to get the second derivative, d2c by dt squared, and sub that value of t in to work out whether it's a max or a min. Okay, so because we're going to differentiate, we're going to have to prepare this equation for differentiating. So I'm going to bring t obviously to the top line here. So we're going to get c is equal to 12t to the minus 1. Remember, change the sign of the power when you move a letter to the other line. And then we've got plus 3/4 times t squared. Okay, let's work out dc by dt. It's the same idea when we were working out dy by dx. So we're differentiating with respect to t, so multiply by the power, we're going to get minus 12t, and then subtract 1 from the power. Multiply by the power here, we're going to get plus 6/4t, and then subtract 1 from the power, we're just left with t. Tidy it up. So what I'm going to do is I'm going to bring t back to the bottom line here and cancel this fraction. So we're going to have minus 12 over t to the positive power of 2, and then plus, and then we're going to have 3/2t. So we've worked out the first derivative. Now, in order to get the time for which the cost is a minimum or a maximum, we're going to set dc by dt equal to 0, because at the turning point, that's where dc by dt equals 0. That will be when c has its maximum or minimum value. So c is a minimum or maximum when dc by dt is equal to 0 at the turning point. So we now have minus 12 over t squared plus 3/2t is equal to 0. Okay, let's solve for t then. So the smart money here is you've got a denominator of t squared, you've got a denominator of 2. I'm actually going to multiply through by a product of 2t squared, because then that will get rid of both of these denominators. So I'm going to multiply through by 2t squared. So obviously t squared here will cancel the t squared we're multiplying by, so we'll be left with 2 times minus 12 is going to give us minus 24, and then plus, again 2 down here will cancel with the 2 of the 2t squared, and then we're going to be left with 3 t cubed, and that's just going to be equal to 0. Okay, plan, going to divide through by 3. So we're going to get minus 8 plus t cubed equals 0. Move your minus 8 over, t cubed equals 8. And then we're going to take the cube root, t equals cube root of 8. Remember, when you take an odd root, there's only one answer. You know, it's not like an even root where you get a positive and a negative. There's just going to be one answer. Cube root of 8 is just going to give us 2. Now, we call this the critical value of t. In other words, the value of t which makes the cost a minimum or a maximum. So that is the critical value for the other variable. So what we've done is we've answered part of part A. We've worked out the value of t, the time at which c will be a, well, they're saying a minimum, but it could also be a maximum. So what we've got to do now is prove that the cost is a minimum when t is 2. In other words, we're finding the nature of the turning point. Is it a maximum or a minimum? So we need the second derivative. So now we're going to prove that c is a minimum. So we need the second derivative, d2c by dt squared. Okay, it looks a bit weird because we're no longer working with y and x, it's now c and t. So, get the second derivative. So d2c by dt squared. So what we have to do is go back to dc by dt and differentiate again. So differentiate again, so we're multiplying by the power, so we're going to get positive 24t and then subtract 1 from the power. So we're going to get 24t to the minus 3. So 24t to the power minus 3. And then differentiate the second term here, well, which is 3 over 2. We're just going to be left with the coefficient of t, okay, because the power of t is just 1. So it's just plus 3 over 2. Okay, what I'm going to do now is bring t back to the bottom line, so make its power positive. So 24 over t cubed plus 3 over 2. Now, what we're going to do is we're going to sub in the critical value for the other variable t, and then if d2c by dt squared is bigger than 0, then that proves that c is a minimum. So let's see, when t equals 2, the second derivative is going to be 24 over 2 cubed plus 3 over 2. So we're going to have 24 over 8, so that's going to give you 3. 3 plus 1.5 is going to give us 4.5. So we've got 4.5, which is clearly positive, so that's greater than 0. So that's telling us it's a minimum turning point. In other words, the value of c is a minimum. So therefore, c is a minimum. Okay, so there's quite a bit to do in part A. Not only do you have to get the value of t that makes the cost a maximum or a minimum, you then need to prove, even though it didn't explicitly say, you then have to prove that the cost is a minimum for this value of t, okay, which we've done. So we've now fully answered part A. Part B then, if we flick back, part B says calculate the minimum cost. So you're now subbing that critical value of t into the original equation to work out what the minimum cost actually is. So part B, So we want the minimum cost. So when t is equal to 2, that's the critical value for the other variable, 2. We're going to sub it into the original equation for the cost. So c equals 12 over 2 plus 3 upon 2 squared all over 4. So tidy that up. 12 over 2, we've got 6. 2 squared is 4, divided by 4 they cancel, so we've just got 6 plus 3, and that is going to give us £9. So that is the minimum cost when the time is 2. Okay, so the cost doesn't get any smaller than £9. Okay, let's look at part C. So part C says, find the time for which the cost is increasing. Now this is the little topic or little bit we did in the previous lesson. To get where a curve, because essentially this is the equation of a curve, to get where a curve is increasing, we set the first derivative bigger than 0. So we're going to set dc by dt bigger than 0 and solve to get the time. So cost is increasing when dc by dt is bigger than 0. And again, we've worked out dc by dt already, so we'll flick back to part A. There is our dc by dt here, minus 12 over t squared plus 3 over 2t. So minus 12 over t squared plus 3 over 2t, so that's dc by dt, and we set that bigger than 0. Again, multiply through by 2t squared. So what we're going to get then again is minus 24 plus 3t cubed, and that's greater than 0. We're then going to divide by 3. So again, we're going to get minus 8 plus t cubed is greater than 0. Okay, in other words, t cubed minus 8 is bigger than 0. Now, we're solving a cubic inequality, so it's not linear, it's not quadratic, so we're going to have to get the critical values. So we're going to have to ignore the inequality sign, get the critical values for t, and then we're going to have to investigate the sign, sign, of t cubed minus 8 around the critical values. So it's not a linear or a quadratic inequality. So therefore, we have to investigate the sign, sign, of the non-zero side, so of t cubed minus 8 around the critical value. Okay, so let's get the critical value. We've actually done this before, but anyway, so critical value so ignore the inequality sign and just treat it as an equal sign. So t cubed minus 8 equals 0. We're going to get t cubed equals 8. Take our cube root again, so t equals cube root of 8 which is going to give us 2. So that's the critical value. So we're now going to investigate the sign of t cubed minus 8 around the critical value. So we're going to rule a table. Top row of the x values, the range of x values that we're going to pick around the critical value. So there's only one critical value, so we're going to investigate the sign of t cubed minus 8 when t takes values less than 2. Sorry, I've put x there, that should be t. So we're going to investigate what happens to t cubed minus 8 when t is less than 2. And also when t is bigger than 2. Okay, so let's chuck a value of t in here that's smaller than 2. Let's chuck in t is 1. So 1 cubed is 1, subtract 8 is going to give us negative 7. So clearly it's going to be negative for ranges of values of t which are less than 2. When we pick a value of t bigger than 2, let's pick 3. 3 cubed is going to give us 27. Subtract 8 is going to give us 19. So that's going to be positive. So we want to solve this cubic inequality. We want to work out when is t cubed minus 8 bigger than 0. So t cubed minus 8 is bigger than 0 for t values which are bigger than 2. So in other words, what we're saying is the cost is increasing when t is bigger than 2. Okay, so therefore cost is increasing when t is bigger than 2 minutes. Okay, and that's our answer to part C. It makes sense because if you think about it, right, in part A and in B, you were working out essentially the turning point and you were showing that C is a minimum. Remember, we were actually getting the minimum value of C, and we knew that the minimum value of C occurred when t was equal to 2. So the cost is increasing again for values of t bigger than 2, because if you think about it, the cost was going down and down and down until you got to the minimum cost at t equals 2, and then the cost is on the rise. It's increasing again, so it makes sense. Cost is increasing again when t is bigger than 2. Okay, so that's our answer then for part C. Okay, last bit, part D. Part D says, find the rate of change of the cost after 4 minutes. Rate of change of cost means you're differentiating the cost with respect to time. So rate of change of cost means dc by dt. It's just a fancy way of saying differentiate the cost with respect to time. So we're going to work out what dc by dt is when t is equal to 4. So part D. So we need dc by dt when t is equal to 4. Okay, so what was dc by dt? If we go back, way back early on in the question, there's the expression for dc by dt. So we're going to copy that down. So dc by dt is minus 12 over t squared plus 3 over 2t. Okay, we're now going to sub in t as 4. So when t equals 4, dc by dt, in other words the rate of change of the cost, will be minus 12 over 4 squared plus 3 over 2 multiplied by 4. Okay, so we can type it in. So that's going to give us 5 1/4. Okay, so in other words, the answer is dc by dt, the rate of change of the cost, is 5 1/4 pounds per minute. In other words, £5.25 per minute. Okay, the rate of change of the cost when t is equal to 4.